Hi, welcome. Today we are going to talk about the universe from a tiny macro level to the gigantic macro galaxies. So this is brought about by the Real Learning Center, which is focusing on real learning. So let's concentrate on universe today. So let us say what it is made up of, how small microorganisms are, and how big the galaxies are. So let's get a peek into these things today. So let's start from asking a question: what is our universe? So is our universe what we see today in our own eyes, or is it something smaller or something bigger? So our universe actually starts at a very small, tiny level. So all the things what we see are made up of something called as atoms. So the atoms are the bricks of our everything that we see around, and these atoms are in turn made up of other particles. So if you ask a question, what is atom made up of? Atom is made up of something called as nucleus at the center of the atom, and a lot of electrons are going around, jumping around everywhere. So the first journey, our journey at the micro level, actually starts to be able to understand what is nucleus. Okay, so the nucleus is the first level that we talk about, and the nucleus contains inside these protons and neutrons. There are two kinds of particles called protons and neutrons. These are not actually stationary; they are just jiggling and moving again. Okay, these protons and neutrons constitute the nucleus. So once you take the nucleus, and around the nucleus, if you sprinkle around the nucleus lots of electrons, then it becomes an atom. So the atom is a very big thing when compared to nucleus, but atom is a very small thing when compared to the things we see around. So the next step in our journey is actually atoms. So atoms are nothing but nucleus in the middle, where there are some protons and some electrons, and around which there are lots of electrons are basically jiggling around, moving around. That is basically called atom. So there are various kinds of atoms: a copper atom, iron atom, hydrogen atom, all sorts of atoms. So these atoms themselves are not the end in itself. So we don't only see atoms, we see molecules. So we see atoms joining together in so-called chemical bonds, and they form molecules. These molecules actually give us a lot of diversity in around our world. So the next thing what you see is actually the molecules. So the molecules are the combination of multiple atoms. They stick together to each other based on what we call chemical bonding or molecular forces. So they join together and form different kind of molecules. For example, two hydrogen atoms and one oxygen atom join together to form a water molecule, and that's water. And water actually is very different from hydrogen and oxygen. It is in itself a different kind of material. So similarly, there are many different kind of molecules. The huge molecules, small molecules. What you are seeing there is a huge molecule. It's an organic molecule, which is being shown here. And these molecules in turn form very complex molecules and structures inside the living organisms. So what you see here, next one, is a very interesting place where it's like a factory inside a human cell or any plant cell. So this is a factory which builds our body. So these are all actually proteins. Our body is made up of proteins, you know. These are all built inside the factories called cells. Inside the cells, it builds based on certain instructions. Those instructions are all coded into DNA and RNA. So based on those instructions, like a recipe, it is there in DNA and RNA. So whether to build an eye, whether to build a hand, all these are put inside those instructions, and that is basically taken inside the cell. Inside the cell, these are all present. Inside that base, it starts building the proteins which are needed for us. So this is what you see there is actually a protein factory. Okay, what you see in strings are all called messenger RNA strings. So they are actually building the proteins needed. So now we have actually come from nucleus to the atoms to molecules to big molecules, and they are getting built, the proteins. So these all huge factory is actually it's a huge factory. When I say it's really not huge, it's huge compared to an atom, but it is very small, and it is inside things called cells, and these cells are what we are all made up of. All living beings, including humans or plants, every living being is made up of multiple cells. There are some living beings which are made up of just one cell, like amoeba. Okay, but we are all made up of multiple cells. So these cells divide and we grow. Okay, and we are all organisms, called organisms. Either it is an individual like human being, or it is a tiger. All of them are actually called as organisms. They are built by cells, and those cells are built by molecules, and those molecules are built by atoms, which were built using nucleus and electrons. That is the story up to here. And now, where are we? Where are we? We are there on this, our home called Earth. So on this Earth we are standing. We are living on this Earth. And now, where is our Earth? Our Earth actually is going around the sun. We know that Earth is going around the sun. And you can see that it is zipping around the sun, not just Earth, but the other planets. All of them are going around the sun. The Jupiter, the Venus, the Saturn, all of them are going around the sun. And what is sun? Sun is simply a star. It's like many other stars in the sky. In the night, if you see, there are so many stars. Sun is just another star in the sky. And what you see here is actually a lot of stars, like sun. These are all different stars. These stars are no different from sun. So some of them may be slightly bigger, some of them may be smaller, but they are all stars. Okay, so those all stars are bunched together. Okay, the huge bunch of stars are called is actually forming a certain shape, and that is what we call a galaxy. This galaxy, our galaxy, is called a Milky Way galaxy. It has actually around billions of stars. So those all billions of stars are just going around in the galaxy around the center, called as a black hole. Okay, that galaxy, such galaxies again, such billions of galaxies actually is basically our universe. So that is our universe. If somebody asks you what is the universe, universe is all this, starting from nucleus up to the galaxies and the universe. So now what are we going to do? We are going to go and see the relative sizes of these things, how big they are, how small they are. Okay, so let's see what are they made up of. So we will go into a slightly more detail into these things. First thing that we are going to see is the micro world. The micro world is made up of small things. So you can see there's an ant there, and people are taking a ride on the ant. It's from a movie called Honey, I Shrunk Our Kids. It's an interesting movie. You can see that. And you can see the flies, the microorganism is smiling there. It's a virus. And you can see the mosquitoes and all that. So those are all not really microorganisms. You can see in your eyes, but they're tiny. Okay, even if you can go inside an ant and see what is there inside, ant's blood and bacteria which is inside the ant, all that is even smaller. So let's just go smaller and smaller and see what are the things available at every stage. Okay, so let's use a technique to go smaller. Okay, what we do is what I call it as a magical jump to smallness. So if you look at it, there is I start with a small stool. It's about the stool is about 6 feet. 6 feet. Okay. Now, let us say assume that you are standing on the stool. Okay. You are standing on the stool. You want to jump. Jumping from 6 feet is not all that tough. Believe me, we have done it in our childhood, and you can do it. So start jumping from 6 feet. So what will happen? Nothing. You will jump onto the floor and end of the story. No. This is not a normal jump. This is called as a magical jump. So what happens is the moment you jump, as you go down, you also become smaller and smaller and smaller and start seeing the micro world. So how smaller? How small will you become? So let us see that. Okay. So he is now taking a jump now. Just watch. He jumped and became small and vanished into thin air. So where is he now? So let's go slow motion and see what happened to him. Okay. So this boy actually started from here, and I'm going to draw some lines here. So these lines actually tell us 6 feet. Now I'm splitting the 6 feet into 6 lines. If you jump now, you go 1 feet down, 2 feet down, 3 feet down, 4 feet down, finally 6 feet down, you hit the ground. Okay, that's the idea. So 1 feet down when you go down, okay. So let us say our magical jump takes us into 100 times smaller. We are like this and we become 100 times smaller. So very thin, very small. So what do you see then? So the moment you go 2 feet down, you become 10,000 times small. That means at every foot, if you go down, you get 100 times smaller than the previous. So 100 of 100 is 10,000. And then you get again 100 times smaller after that in 3 feet. So like that you continue. Every time you decrease your size by 100 times and continue till you hit the ground and see what will happen. So what are the things that you see? So that is what we are going to see now in the next. So let us now start the jump and see for 100 times smaller, and we slow down and see what we see there. Okay, the first step. So we have now, the boy has jumped now and he's 1 feet down. So he's 100 times smaller. How small is he? You can see there is an ant which is almost as big as him, and there is a mosquito, and there is also a housefly which is coming. And just imagine his horror when housefly comes near him and it's as big as him. So that is the size of this boy. And then you continue to fall. When you continue to fall, you go to the next level. You become smaller by 10,000 times. Suddenly you are seeing, when you become smaller for 10,000 size, and you start seeing very small organisms. These are what we call unicellular organisms, small ones, amoeba. It takes any shape. Amoeba does not have a shape. It takes any shape. So amoeba is actually very dangerous. It gives us, when we get into our body, it gives us amoebosis. It's a disease, dysentery. So that amoeba here is not going to get inside him because he is so small. He is smaller than amoeba. Amoeba can eat him. Okay. You know how amoeba eats? It puts its pseudopodia around its prey and it dissolves him. That is how amoeba eats. So you are in the place where you are smaller than amoeba, and when you see an amoeba, you have to actually run. There is no alternative. Euglena is even smaller, and paramecium looks good. Okay, so these are the stages. This is the stage you are in now, 10,000 times smaller. Now what happens if you go even smaller? Okay, so actually these are these small things like amoeba and paramecium. You can watch, you can see them in microscopes. So you can go and buy a microscope. It's not at all expensive. It's much cheaper than your phone, and you can buy a microscope and watch all these things. So ask your parents. The next one is basically when you jump still further, you are going to basically 10 to the power of minus 6 meters. That is the size. Okay, which is basically 1 by 1000 of a millimeter. What is the meaning of that? You take a scale and you see that inside there is the millimeters, centimeters and millimeters. 1 centimeter has got about 10 millimeters. And you take that one small tiny millimeter and cut it into 1000 parts. And one of them is called 1 micrometer or 1000th of a millimeter. So you become that small when you reach 3 feet down. So when you become that small, what you see is the red blood cell, RBC, which is inside our blood. If you take one cell and that one cell looks this big. Okay, and you know what is a human neuron? So whenever we touch something, we get the communication to our brain, and that communication go through the nerve cells called as neurons. They are like tiny, tiny, small threads with many. They are connected to many more threads like that. They are called neurons. These neurons are quite small, very, very small. So when you become so small as 1 micrometer, 1,000th of a millimeter, these neurons will look like a huge tree for you. Okay. And the most dangerous thing for us on this earth is this, the virus. Virus is the most dangerous thing because it can cause diseases to anybody, not just us. It causes diseases to bacteria. So virus can enter inside the bacteria and it causes diseases to bacteria. That is the beauty of virus. It's so dangerous. So these viruses are extremely tiny organisms, very tiny. Okay. And they are thousands of times smaller than bacteria. Okay. So they can cause disease to anything, and getting cured of viral diseases is the hardest thing. Okay. So when you are here at the 1 micrometer, that is where all our living cells and all those things, their sizes and all we have seen. Now we have to get to, even when you go slightly more down, another feet down, what will happen? You are going to now get inside the cell. Inside the cell is a huge factory. Okay, so many things are going on inside the cell. So we are going to now see what happens inside the cell. So you are actually now inside the cell. So it's a huge place, and you are so tiny. You are 10 nanometers. Okay, 10 nanometers is how much? You take 1 micrometer and cut that into 1,000 parts. You get 1 nanometer. Such 10 of them is 10 nanometer. So now you are in 10 nanometer scale, and when you are there, what you are seeing there is a DNA. What is DNA? DNA is a recipe of life. It contains the instructions on how to create our body. Okay. It's not only in human beings, in every animal. So the way you are created by the DNA, it happens inside the cell. In every cell has DNA. Every cell. Okay. It contains a copy of a DNA. So it contains instructions in terms of chemical bonds. So our cells actually read it, and messenger RNA takes it, and you saw how it builds the proteins and the whole body itself, how to build the body. That whole set is there in that. Now, when you go to this scale of inside the cell, those small instruction sets which is written in the DNA look so big for you. So you see, so big. And I am also showing you on here called as carbon nanotubes. So carbons actually are available in many allotropic forms. You must have learned about that. Carbon is like a charcoal, coal, and diamond. All those things are graphite. These are all naturally available carbon forms. But human beings, as we have created some new carbon forms. They are called carbon nanotubes. Okay, they are very tiny and very powerful tubes, which can be used to create a lot of in industry. It can be used to create a lot of strong things. Okay, carbon nanotubes can also be used to create small, tiny robots which can go inside your body. You can inject a robot into your bloodstream. It can go inside and find out where the disease is and cure and come back. So such things can be made using carbon nanotubes. So now you are at the scale of carbon nanotubes, so small. Okay, so that is basically 4 feet down. We still have 2 more feet to go to hit the ground. So we are already 10 nanometer level. Okay, now let us see what will happen even if we go further. Okay, what will happen? If you go a little further again, 1 feet further. Okay, you are just now 1 feet above the ground. So you are already starting to see atoms. Okay, atoms are the basic building blocks of everything that gets created. The hydrogen atom is the tiniest carbon atom you can see, and the cesium atom is supposed to be one of the biggest atoms. Okay, biggest means in terms of size. Okay, in terms of mass, you can see uranium and all are bigger. The size cesium atom is very big. Okay, so you are already at the level of atoms. Atoms means what? Atoms means nucleus and around which electrons are going around. However, you have to understand that the nucleus is extremely tiny, and the electrons which go around the nucleus, they are very far when compared to nucleus. Like if you take, for example, nucleus to be of one tennis ball size, the electrons which are going around them are like 2 kilometers away, 4 kilometers away from here. So such big is the atom when compared to nucleus. So if you go even further down by 1 more feet, okay, what are you going to hit? Are you going to hit the ground? So you know what is happening now? You are already 6 feet down. You are on the floor. So are you hitting the floor? That is the question. Okay. You may not be hitting the floor. You will not. You know why? That is because you are so tiny that you go through the floor. Floor becomes transparent to you. And you know the electrons and protons are all there, but they are all so far, 2 kilometers away. One nucleus is there, and somewhere else there one electron is going like this. So all that is happening to you, but you are still falling down. You are actually not stopped at all at 6 feet level. So you have not hit the ground, and you have disappeared. Nobody can see you. So if you go even further down, 1 more level, now you are getting into femtometer range. 10 to the power of 15, minus 15 meters is 1 femtometer. So now I am talking about 10 femtometer. So now you are starting to see the nucleus. Nucleus is in the center of the atom. We are just starting to see the nucleus. And the nucleus, biggest nucleus, like uranium nucleus, actually you can see as like a football size. And the protons are like small, tiny things going around here. So you are almost at the level of the size, less than the size of the nucleus, uranium nucleus. So that is where we can't go any further. Okay, we can't go smaller than the neutron and find out, because we don't know how they look like. The whole world is called as a quantum world, where things don't stand simply. They are all jiggling around. And there's a lot of things called probabilities coming into picture. So I will not talk about the quantum world now. That we will discuss in another day. So here we have reached the end of what we can reach at the micro level. That is the end of our journey into smallness. Okay. So the next we are going to get into the gigantic universe, the bigness. Our journey into bigness, called as the macro world, starts now. So let's discuss that in the next part. Thank you.